Welcome to the Azure Global Azure Bootcamp 2023, and it's my session about Azure Quantum for Future. Now, something about me. Who am I?
Okay, please put your mobile on silent. Thank you.
My name is Megha Pandey. I'm a Gold Microsoft Learn Student Ambassador, 2023 Windows Insider MVP, an ex-quantum AI engineer at STEMIC, and currently a Wipro Scholar Trainee. So I think that's too much about me, and let's get started about how quantum is going to change the future. Now, first of all, a lot of people might be guessing, do have a doubt, like what is quantum? Quantum is a kind of energy, it's the smallest part of energy, which you can see. Okay, each and every element, whether it's in benches or dexes or maybe in the system as well, they have minute particles, and each minute particles does contain a kind of energy called as the electromagnetic energy. In simple words, we can say it's a kind of quantized charge which each and every element possesses. Okay, so what we are going to do over here is we are going to take these kinds of energy, the potential of these kinds of energy into a quantum system, and taking a computer, making it in the form of QPU, and displaying it to all the people. Now, here are a lot of principles. Since you must have heard a lot of principles in your high school about quantum computing, or maybe about Avogadro's principles and a kind of principles, many of them. But over here, we are using only 3 principles. One of them is superposition, the other is entanglement, the third one is interference. Now, how is going to use these kinds of principles on a quantum system? The quantum system logical gates are made out of these all 3 principles, and the logic actually built and the solution actually made is all over placed on these principles only. Okay, so if you wish to like add on everything, you can just write it over here or maybe mention it somewhere, because these are the major quantum principles that are used throughout, whether you are a advanced student in quantum computing or whether you're a beginner. You just have to start with the 3 principles of quantum computing. Now, the superposition, the first principle. Now, the meaning is the ability of quantum system to be in multiple states at the same time until it is measured. Let's take an example. There is a box over here, and there is a cat inside it. Along with the cat, there is a radioactive material. If the cat inside the box moves, the cat will die. The radioactive element would fall, and it fall over the cat, and the cat would die. Okay, if the cat doesn't move, she will be alive. Okay, he or she will be alive. So until and unless you open the box, you won't be able to signify whether the cat is dead or alive. So at that present moment, I want to know whether the cat is dead or alive. I would suppose of 2 probabilities. Either the cat is dead, either the cat is alive, or 50 and 50%. That means the cat is dead and alive at the same moment, at the same time for me, until and unless I open the box and I check, right? So this is the quantum principle called as superposition. Means you are between 0 and 1, like 1.5. The second thing is entanglement, the ability of particle to be at 2 states. Now let's take an example. This was actually discovered by Albert Einstein. Let's suppose there are 2 boxes. In one of the box, you have kept a red ball, okay? And one of the box, it's empty, okay? You and your friend takes one of the box, okay? You shuffle both of the box and you give one of the box to your friend, and you take one and you go to the end of the universe. Let's take an example at the end of the universe. Or to be more practically, you go to the North Pole and your friend goes to the South Pole, okay? Now, one of the person out of these 2 open the box and finds it to having a red ball. So automatically you will know the other person over there on the North Pole or the South Pole has an empty box, right? This kind of creation or this kind of lining that the two states have connected each other, it's called entanglement. Whether you are in any part of the universe, whether you are anywhere, you just are connected with each other in one of the states, and the state is the balls and the boxes. This is called entanglement, getting entangled with one another through one line. Now, interference. Quantum interference is when atomic particles interact with and influence themselves and other particles while a probabilistic superposition state. Now, it's just a definition, but to be honest, let's take, how many of you know what is atom? Yeah.
The smallest particle.
Okay.
Smallest particle. Then there will not be something called subatomic.
Subatomic, when you just go into the lower core level of that, and that can be a proton or neutron.
और चलो भाई सब लोग तो SSC दिए हैं.
Well, now tell me, what is an atom, whether it's a wave or particle? Now, you must have heard about this.
It can be both. Like
Yeah,
either
both.
of them.
Why?
Like depends on its state.
Okay. Can you give me an example about the same?
Any solid or gaseous, whatever.
No, a particular state where it acts as a gas, as a wave and a particle both.
Wave, like maybe in electromagnetism.
Okay, like how? A clear kind of example. Okay, no worries.
No,
You
no,
are
that's a really good point. I mean, these guys you must have done 10th level, 12th science. Who's not done 10th level, 12th science? I'm not talking about engineering. 10th level, 12th science. कोण नाही केलं हात वरती कर. मतलब सगळ्यांनी केलं. Okay, so what she's asking is very deep. So atoms, that's what both the properties, right? A waveform as well as particle. There were two major experiments that were done to validate them. They're quite famous. You must have learned this. Which one?
Have you heard about the principle wave-particle duality? Okay. I guess these students have to learn physics a little bit more.
So you all have your string theory? String? Just heard of it.
It's been heard by us in Big Bang.
Yeah,
Okay.
Big Bang theory.
Okay.
Okay. Just take an example. When there is an image over here, okay? Now, what happens that the atoms have been shot out over from here, and you see they are not passing fluently. Like they should come out like this now. If they are coming from here, if they are coming in a circular way, and they should come out over here in a circular way only, right? But instead they are falling like one or the other in the opposite sides. Why it is happening? It's just an example of sun. Okay, sun possesses both kinds of energies. The elements, it has some kind of power. Okay, and it acts as a particle. The tiny particles which you see on the sun, they are known as the particles. But still, when you feel the heat waves during the summers, the very, very, very kind of simple example is of the sunlight. You can see the sunlight, the tiny particles of the sunlight in between the sunlight. So you assume it as a particle. And on the other state, whenever you feel the heat waves, you call it as a wave. Okay. Now, quantum computers work on qubits. A normal classical computer works on bits, like 0 and 1. What is known as, what do we call it as?
Binary system.
Binary system. Okay. Can someone tell me the binary system, the binary number of A?
Binary operation.
Yeah.
This is hexadecimal. This is hexadecimal.
Yeah, hexadecimal.
No, binary is different. Hexadecimal.
0, 1, 0, 1.
0, 1, 0.
It is converted actually. Okay.
0, 0 is for.
Like you can interpret out of 0, 1, 0 when you can interpret the whole words,
0, 0
the whole sentence also. Anyways, I think just get the answer until the brain booster arrives. Okay. So the qubits are the particles or the bits of a quantum computer. Like for a classical computer, we have CPUs, central processing units. For a quantum computer, we have QPUs, the qubit processing units, okay? Or the quantum processing unit, both of them. Now, over here, the qubit possesses 3 states: the 0, the 1, and the 1.5. Over here, you can see a 0 plus 1. I think it just cut up over here, and root under 2. Okay, so it is something between 0 and 1. This 0th state and the 1 state. So whenever you want to get an answer in the form of decimals, you can get the answer with the help of qubits. You will get the accurate answers over here because the points over here are reflected directly, like which are not reflected on the bits or the binary systems. Now, Azure for quantum. Now, Microsoft has ample and ample of resources which are actually used for quantum, or maybe a lot of other languages and a lot of other domains. For me, I basically work on Azure for quantum. The Azure, you get the ability to use the cloud computing of Azure, and you have to have a quantum computer. Now, the actual quantum computer is very, 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 very costly, and it takes around, billions and billions of dollars to build a system, because in a quantum computer, the QPUs are actually stored in 0th temperature. They are very, very, very as a very freezing state. The reason behind it is that the atoms which are created are man-made. Okay, the man-made atoms are created with the help of silicon and all the semiconductors. What are the semiconductors? Anybody?
Silicon and lithium.
Lithium?
No, sorry.
जला मत हम लोग.
That is used to power silicon.
Okay. Silicon and germanium, gallium, a kind of thing. Okay, so the elements who have 5 in their outer shells. Okay, just remember this. I think these keywords are very easy to remember. So these kinds of elements, what they do, they have a high power to connect with other elements. Now they have very broad valence state. So they can pass from one element to other elements, and they can connect with each other very easily. And they are known as the semiconductors because they can connect with, they can conduct electricity, and sometimes they cannot. That depends on the element which is connected with them, right? Now see, these semiconductors, what they have a vibrant. For each and every atom, they have a vibrant, and they have very, very, very low density. So whenever any of the atoms that arise to them, what they do is that they connect with them. Okay, for heat waves, whether it's about heat, whether it's about temperature. You know, your CPU or your system, sometimes it heats a little bit more. What is the reason behind it? Because the atoms, the subparticles present over there, they start heating up. They produce heat. Just like the quantum systems as well, the quantum atoms, the qubits, they start heating up. So to reduce that heat, so they do not produce any kind of errors, we place them in a very 0th temperature, minus 27, I guess.
Degree
So
centigrade or Kelvin?
it's Fahrenheit.
Nitrogen cooling.
Huh?
Nitrogen cooling.
We don't use nitrogen fuel because that's a kind of element now. That's a kind of chemical. So we need a proper. Even the human intervention in between that can affect the heat of the whole quantum system. So cold quantities. So that's why we do not involve any kind of chemicals over here. And they are actually, the quantum QPUs are made of gold, because
Yeah.
who knows that gold
Steel
is one. What is gold?
Non-reactive shining metal.
Yeah.
But it's having a very highest speed of transaction.
Yeah. Actually, the gold cannot connect, they cannot combine easily with each other. Okay, so that's why they are known as one of the gases. other and until and unless we make it in the smoothest form. Like we create an alloy out of gold and then only we wear, right? A kind of complete gold can't be worn. Okay. Now Azure for Quantum. Azure Quantum ensures an open, flexible and future-proofed path to quantum computing that adapts to your way of working, accelerates your progress and protects your technology investment. Okay, that's a simple definition about Azure Quantum. The next thing is Azure Development Kit. The Microsoft has a unique kind of kit which you can use to help your system to run on a quantum system, on a quantum computer, like a quantum computer, right? Isn't it insane when I say that you can run a quantum computer right on your VS Code? So with the help of this quantum development kit, the QDK, you can actually run and you can simulate and answer every kind of answers or every kind of questions over there. Okay, so QDK has a lot of tools. It actually uses a kind of language called Q#. Okay, it's a combination of C#, Java and XML a little bit. So you can say a combination of 3 or 4 languages combined into one, and a little bit of Python as well. Because the codes actually written can be of Qiskit and can be of other languages as well, like Circ. So we can say that Q# is a connection of all 5 languages versus C#, Java, XML, and Python, and sometimes I think Circ as well. Circ also uses Python.
Sorry, what's the fifth one?
Circ. CIRQC. It's of Google. Google uses, like IBM uses Qiskit, Microsoft uses Q#, and Google uses Circ. Providers available on Azure Quantum. Now, since Microsoft wanted to have a scale-up kind of thing in quantum computing, so they use multiple kinds of hardwares from Rigetti, from Quantum, and from Microsoft, and sometimes from Google as well, because it's a combination of all of these providers. They get the scientific solutions right at your end with less and less time, and the amount of time being used over there, it's very, very, very less. So I can say that a calculation which requires around 24 hours to complete, according to Google, it takes around 0.2 milliseconds for a quantum computer to process and answer the question of that particular solution. Now a live demo, I guess I should get started with a live demo, because this is all about the theoretical part, and for some kind of live, you should know how a quantum computer actually works. Okay. So before that, write some keywords which I think would be very useful for us, very useful for both of us to interpret and get the answers. Okay. Now quantum is a combination of maths. If somebody is not good in maths like me, they would be having a little bit of idea about matrices, determinants in matrices. So this is something like matrices. So one of the notation which is known as bracket notation. And the first one is bra and the second one is quit. The bracket notation actually interprets this kind of thing. Let's suppose A over here is 0. Okay. Now we have 2 states, 0 and 1 for a classical computer. Now a quantum computer is actually interpreted from a classical computer only. So it will obviously have 0 and 1, and without 0 and 1 nobody can predict any kind of answers. Okay, so 0 by 1 for a bra, the answer would be in the form of matrices, it would be 0 by 1, and for ket it would be 1 by 0. Okay, it's written incorrect over here. It shouldn't be like this, but in the form of matrices it would be 0 by 1 and 1 by 0. Okay, and a combination of this would be 1 by 0 into 0 by 1. Okay, is there a pen kind of thing that I don't know if I
there
would
is
be.
a marker there.
Okay. Where?
Mark in the wall. Can you see the wall?
Yeah.
Wall behind you.
Okay.
Not there. Make it here.
It's working. I was just checking whether it's working or not.
Not on that screen. Huh?
Yeah, yeah. I know. Whether it's turning on or not, I'm just seeing that. Okay, can you see over here? The value of 0 over here would be something like 1 by 0 in the form of matrices. And the value of 1 would be in the form of this 0 by 1. Okay, now we can multiply now. In the form of matrices, we usually multiply. Can anyone tell me the answer after multiplying? I have aggregate. Okay, let's get started. 0 into 1, it's equal 0, and 1 into 1. 0 and 0. So the actual answer would be 1 by 0. Okay. This is the superposition state. The answer is actually derived from one of the states, but how it is? It is different. The answer would be 0. Of any probability, there are kind of calculations of gates. So whenever you use gates, there would be a kind of C0 gate, H gate, or something kind of gate. Okay, so the value of that gate is multiplied by any of the value, whether it's 0 or 1, and they will give you the answer in between these, or a unique answer in the form of matrices 1 by 0, 0 by 1, or something like that. I know it's kind of mathematics, but once you understand the calculation, you would be very interested to know how the actual quantum computer works, you know. The second is one more gate known as the Hadamard gate and the control node gate, because we are going to create a belt state. A belt state is a kind of entanglement state. Like I told you, that we have to have a kind of entanglement between one or the other state. So this is one of the belt state created by some I don't know the name of some bell. Okay. The gate is edge gate. Edge gate is the unique gate of superposition, I would say. The superposition gate is edge gate, the Hadamard gate. And the second one is the control NOT gate. NOT gate, if you must have heard about computer science only, logical gates. What is the value of NOT gate? What it does actually?
Negation.
Reverse. Very good. Reverse. So when the answer is 0, it will turn. If we apply the NOT gate, it will turn into 1. So the actual value would be 1. Okay. So here we are using the controlled NOT gate. Controlled NOT gate, what it does, it takes two states, the 0th state and the 1 state, the combination of both of the states. Okay. So here is a live demo. I guess we can get started with a live demo. Let's switch back to the Azure Portal. Okay, over here you have to, when you click on the Azure Portal, it will be something like this, okay. And you have to choose Quantum Workspace. You see all of the things that are available in creating a virtual machine on Azure are available on here also. So we will just simply click on Create, and it will take some time, I guess. Okay. For your easy benefit, you can choose any kind of subscription, and after that you have to just click on select quick create. Okay, it will help you to have a simple hardware which will be helpful to run a simple kind of algorithm or a simple kind of quantum code. Okay, we'll just click over there, and I want to name it as Azure Bootcamp 345. Okay, the workspace is valid. The value is between 2 to 54 characters, and you have to align by all of these tasks, and then you have to create it. Okay. For the region, I guess you should use US region because that's where your actual Quantum workspace would work. Now it will take around 4 to 5 minutes to actually create it. So till then, we'll just head off to one of the previews that I have made.
The machine which we are creating can be created in any of the region, or it needs to be in any specific region?
No, it's like you can create it any of the region as per your choice. Now I'll head back to the home because it will take a little bit of time to preview. I'll head back to this Azure Bootcamp demo which I created a few days back. You see, once created, it will take around 4 to 5 minutes to create actually, and it would be something like this. You will see all of the operation that you can see, and the possibilities of quantum computers are on the cloud computers. Like all of them, whether it's about job management, about tasks and alerts, and every of the resource that you use on cloud or on Azure is available on this quantum system as well. A so-called quantum system, I would say. Now we will click, since we do want to have some operations, I will click on notebooks, okay? A notebook, how many of you have used notebooks for coding, like for Python basically? Yeah. So, yeah, very good.
What type of OS will be supported?
Yeah, you have to have Anaconda.
Anaconda?
Yeah, Anaconda.
Yes,
PyConda,
yeah,
yeah, something like that.
Anaconda.
Yeah. It actually installs all of them once you install Anaconda. Okay, now here I have created the simplest form of belt state, which I think it's quite easy to understand because it's my creation actually. So over here, these are the simple things that you have to write. Whenever you write from, if you want to have, upload it from Cascade, you can upload it right from there. Once you create a simple demo, all you need to do is just go on notebooks. Okay, create a new notebook. Over here, click on create new notebook, and once you can name it as I named it as demo 1. Okay, and I want to run it. The explanation is from Azure Quantum. I'm using Azure Quantum, so that's why import workspace. That's a simple workspace, and this is the subscription ID and the location that I have used, and workspace. The value of workspace I have given this file, workspace only. I can rename it as anything. Okay, I'll just run it over here. Okay, done. So it took around only 1 second to run those codes. The second thing is I'm going to run this code, which is I'm going to import all of the Cascade libraries into my Azure Quantum. From Azure Quantum, I have to, since Azure supports Cascade. Cascade is a kind of language which is used by IBM. Okay, so I'm going to use IBM because IBM Cascade because it has very easy understanding Python languages, which are quite easy to understand. They have very simple algorithms. Okay, so I use Cascade, and from Cascade I have uploaded all of the libraries, and this is the name of the actual library that I'm going to use. That is Quantum Circuit. Okay. Now, I'm going to give it a value of quantum circuit. We are using over here 2 bits, 2 qubits, and 1 classical bit. Okay, this is the classical bit, and this is the qubit. I'm using 2 qubits and a 1 classical bit. You see over here, it's written C. Over here, you see?
Yes.
That means I have used 2 bits and 1 classical bits at the end of 2. The first thing happens over here is that I will rename it as QC1. This is the simplest one. I am using Hadmat gate. The Hadmat gate over here is this one. this is the Hadamard gate. The value is, I've shown you earlier, 1 by 2, 1, 2, 3, and something like that. And the X over here is a C NOT gate, controlled NOT gate. What it does is, you see, there was an entangled state, controlled NOT gate, there was a circle or something like this. A dot, and over there below, there's a cross. Okay, so it was something like this. This is the actual value of C NOT gate, and the Hadamard gate, the zeroth qubit and the 1th qubit is connected together. And after that, what I'm going to do is, I'm going to measure both of the states. Now, this is a simple Bell state where I'm using a Hadamard gate. A Hadamard gate can be named as a qubit state, a qubit control bit gate, which is basically used whenever you are performing any kind of operation related to quantum computing. You should always have you will always see a Hadamard gate over there. So just for an explanation, I placed it over there, and a control bit which helps to create an entangled state. And after that, I'm going to measure it and print the actual value, which is 1. Like, after calculating the values of everything, the value came out to be, after measuring everything, it came out to be 1. Now you can import any kind of library like matplotlib or Python and NumPy, or import math or something like that, and you can print it over there in a way of graph. That's totally optional. And then moving ahead, why Azure Quantum is future. Now, a lot of students might be asking, might get a doubt, like, why do we use Azure Quantum in the nearest future? Why are we going to use Azure in the nearest future? The basic reason is that since your laptops and your devices do have the microchips, now how about what would be the evaluation after this microchips? There would be something called quantum computing, which will use artificial atoms, because they are very, 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 they can be created in minute particles. They take like less space. Nanoparticles, okay. After macro, it will be nano. And what about nano? After nano, it should be, or it might be quantum. So quantum is going to take the universe, or to take the world in recent 10 to 15 years. So it is very, very, very helpful for one of the person to learn these kind of technologies. And by my experience, I think that a lot of people in India, they have the theory of the theoretical knowledge of quantum computing rather than the practical. So a majority of people have moved to different countries, and that was the major reason why I wanted to show off this kind of Azure Quantum kind of paper to other people as well. Like, quantum has a lot of potential, but we do only have the idea about the theoretical knowledge, not of the practical knowledge. So maybe in future we can get the solution regarding the same if we learn about these kinds of technologies. Okay. The second thing is upcoming areas of quantum boost. I think I should present it. Okay, the first one is agriculture. Now, can anyone tell me how quantum can help in agriculture kind of field? You must have heard about nitrogen fixation. Okay, what it does actually is it grabs the atmospheric nitrogen and it converts it and it gives to the plants. For plants and crop yielding, nitrogen is the major. It's a very major kind of element or the compound that has to be used. So the crops yielding is very fast, or it's very fruitful. Okay, so the amount of nitrogen is available on the earth, it's about 78% or 77%, something like that. Okay, now nobody knows how to grab those kinds of nitrogen from the universe, from the earth to our land. Okay, with the help of quantum computer, we can learn about the fertilizers. We can know, because nitrogen can be named as the most complex kind of element in the periodic table. Nobody knows how to grab the actual calculation that can be performed to get the answers. Now, everybody knows to perform any kind of experiments, one need to have a certain kind of calculation. Without calculation, we cannot predict the answers, right? So for that kind of calculation, quantum computers, whether a simple classical system takes around 13 days to perform a calculation, a quantum computer will take less time, plus it will generate a simplified ideas that nobody knows. Like, you can't predict the answer, and you will get a probable answer over there with the help of a quantum computer. So for nitrogen fixation and for fertilizers also, we can replace the man-made fertilizers with the help, or the artificial fertilizer with the natural fertilizers with the help of quantum computing. If we do the calculations, again the calculation arise, and you can even predict the actual experiment that can be performed. Now, other thing is the cyber security or the cryptography. Now, I think a lot of people must have heard about quantum cryptography. If you are on the web, or maybe on Twitter, or maybe on LinkedIn, you must have heard about quantum cryptography is taking the world. And why? Why is the reason? Now, one of the famous scientists, Richard Feynman, who wrote about quantum mechanics, you must read his book, one of the books, How I Started Quantum Computing. It's just like, it's not about the theories of quantum mechanics and theories of quantum computing. It's actually the story of how Feynman introduced quantum computing or quantum mechanics into real life. Okay, that's a very interesting book. I should recommend you. Maybe in future you should read if you get time. The only computer that can break the chain of cryptography is quantum computer. So nobody knows that the actual system, the actual cryptography can be broken with the help of quantum computers. That's why a lot of people are talking about quantum cryptography, because the chains of cryptography, the actual reason or the amount of coding being used in cryptography, or the amount of calculation being used in cryptography, you can the simple quantum computer can decrypt it very easily. And that's why he wrote this. The only computer can decrypt the cryptography chain is quantum computing. So that's why, just ahead of all the hackers, we should adopt this kind of quantum technology to answer these kinds of questions. And maybe in future we can save a lot of people from getting cyber hacked. Okay, the third thing is data processing. For people like data analysts over here, I think a lot of people are there if they are working. The amount of data being present in the universe needs to be processed and managed. And for that, you need to have a scientific kind of calculation where we are not focusing on the algorithms or the calculation being performed or the answers, but we are focusing in one element, which is M, P, Q, or any of the elements. You know, whenever we derive anything, we have a simple kind of formula like this, or psi, phi, which possesses a little bit of amount of energy or amount of calculation or amount of number over here.
Constant.
Yeah. So, pardon? Did anyone say anything? Maybe I missed one. Okay. So, if the answer is A is equal to B and M, we are focusing on the M. And with the help of this quantum systems, with the help of quantum algorithms, we can get the actual process being involved to get an answer. There are major kind of algorithms. One of the algorithm is factoring algorithm. Anyone knows one of the factoring algorithm, which you must have heard in standard 11, 12, 10, or maybe something like that. A factoring algorithm. I think everybody is blank about quantum computing. Okay, it's Grover's algorithm. Grover actually won this Air Nobel Prize for this algorithm, which is Grover's algorithm. Grover's factoring algorithm. Okay, this can predict the future impacts or the future answers, just like an artificial machine. we teach them, okay, for an artificial intelligence machine, we have to teach them in the form of supervised learning, and then we give them some tasks, and before that we do a calculation, okay, with the help of these algorithms. One of the algorithm is the least square temporal difference, which is square the amount of energy or the amount of work I am giving to that particular machine, which is artificially intelligent, okay. So we just predict the answers, and the number of time it does any kind of mistakes, we just detect the amount of some amount. Like in exams, what you do is, if you take a correct answer, you get 1, and if you do a wrong answer, minus 0.5 or something like that. So the same thing I'm doing with a machine, and this machine has ample and ample of data, just like Google. So for that, I have to have an algorithm that can proceed and that can show all of the answers in one form or in a one way. So for that, I think quantum computers can predict the best algorithms in the near future by the amount of data being present in the world. Acha, tell me one thing. How much data is grabbed? How much data is processed in one day, in a single day, in the whole world?
Some zettabytes.
Yeah. Okay. What is that particular value? Just search it.
Okay.
Whenever I have asked questions, write it somewhere and search it. You will find the unique kind of answers. And I'm not going to tell them. Because once I tell them, you won't be searching it anywhere, and you will forget it after the few days. Okay, a brain booster where you can ask me questions if you think. Do we have time left?
We have
Power 21.
Okay, so any kind of question which you think might be helpful?
So for quantum computing, what kind of operating system we can use?
What kind of
OS we need, to process it, like on the top of the hardware we need some
kind of OS? It uses a
sort of
normal
OS,
operating system. You know what?
आप client use करने वाला है, that is the point, man. You're going to use client, not the server. आप कोई quantum computer set ना करने वाला है आपके laptop पे.
But on the server, like what kind
Which
of
server?
OS we can install? Whatever we are going to launch on the using Azure service,
Yeah.
that space you will get, right, of the hardware. So on top of that hardware.
So आपको क्या है? You are getting the client to talk to it. आप थोड़ी quantum computer set करने वाले हो.
Okay, तो Azure कौन सा वो यूज कर रहा है OS?
Azure कौन सा use करे सर? मान.
Azure भी तो OS यूज करता होगा ना?
शायद, but I think so that is a business secret.
Normally they don't use operating system, they use something called as a processing engine. Because what she is showing is that you will be applying an algorithm as a script.
Right.
For example with Python. So all you need is a, let's say any editor
So that integrated
or a
with
notebook.
Yeah.
हाँ तो वो processing engine होता है.
processing engine they use.
So it's a cross collaboration across all industry leaders. Google is also contributing to it. AMD, Intel, both hardware and software vendors they all play together because it's not one person's job.
Exactly.
Yeah, but for quantum computer अलग है. They have proprietary stuff that are happening, each of them, because it's a different. But you are not supposed. There's no आपको उसको कुछ सोचने की जरूरत नहीं है. आप सिर्फ client बुला रहे हो. मतलब you're calling API. ये समझो.
So you'll be
You are
writing
not
algorithm
running
to
any
solve a
of it.
problem.
About the operating system, you can also run your codes on Visual Studio Code also. The quantum system algorithms can be run on normal Visual Studio as well. So,
APIs are there, no?
yeah, there are certain kinds of. It actually uses the Azure only. If we create a local machine, if we create an Azure the local machine, and then over there we run our codes, and they can be saved in multiple forms. But once you run them, you have to have a space, a certified space for that particular thing. Any more questions?
Is quantum just theorized, or there are actual practical use that have been implemented and money is made from them?
Okay.
So So we say that it can hack cryptographic and everything,
Yeah.
but has that already been done
Yes,
somewhere
yes,
in
it's
any application?
actually done. You know what? There was a case where, I don't know if you must have heard about this. Girls Quantum posted that one of the person who was a, why did I mention about hackers? You know what? One of the hackers learned about quantum cryptography, and they actually implemented to grab some data of someone. I don't know. The names are not disclosed yet, but there was someone whose data was grabbed, and he was an engineer. He was a quantum engineer. So once when he found out that he actually used the quantum systems, the quantum algorithms to just find out what was there in his account or something like that. He used tremendous kinds of algorithms which are not yet predicted, not yet processed. And for other thing is that just like artificial intelligence, it doesn't have a unique kind of definition, like you all know. The same thing happens with quantum computers. These are things that need to be discovered. They have to be discovered in the nearest future. And one more question: if people are making money, you know about Regity? Regity uses Regity is a hardware company of quantum, and they use this quantum hardwares to take out the answers of the global warming. Okay, the amount of gases being produced each and every day in a particular area. Like this is the campus, and amount of gases like carbon dioxide being released each and every day, because the amount of people coming overhead, sometimes it's less, sometimes it's more. So what they do is they cover up this area and they calculate, and they come out with the help of quantum computers. They come out with an easiest kind of calculations that they can use, and after that what they do is they predict the answers, and they use this idea to implement it in the real world. Okay, I hope you got it. Any more questions? Okay, I'll ask some questions, which I think two questions. Okay, if you must have heard about everything very precisely and in a consideration way, what is one of the factoring algorithm? Okay. The second thing is, how can you explain superposition and the three quantum principles? Any of the questions? You can just.
Superposition, entanglement, and interference.
Okay. Great. That's good. Okay. Thank you so much for inviting me over there. That was a great
Thank you so much.
Thank you.
Okay, how many of you have tweeted?
Yeah, that's me.
Posted who? What have you done? Megha, can you show? Let's see what
Okay.
they
Let's see.
on the big screen.
Oh, I will see you.